In this video, we're going to do a quick trigonometry recap before we move on to all the new identities. The reason why I'm doing this is because I think sometimes people can get a little bit lost with all the trigonometry rules that we have to learn, and it does feel quite abstract, especially when we get onto the identities. And I just want to try and remind us of what this trigonometry is all about, really, just so it doesn't feel as abstract as maybe it might do. Okay, so let's start with the basics. Right angle triangle. Okay, you've got a right angle triangle, you've got an angle which is called theta, you've got your opposite side, you've got your adjacent side, you've got your hypotenuse. So don't forget, sine theta is literally just the ratio of the opposite and the hypotenuse. That's all it tells us. What sine, if you do sine of 30 degrees, it will tell you that the ratio would be a half. So if that was 1, that would be 2. Okay, that's all it means. Cos theta is just the ratio of the adjacent to the hypotenuse as theta varies. And tan theta is the ratio of opposite over adjacent. So obviously in the last video we were looking at cosec and sec. If you think about sec theta, that's 1 over cos theta. So if you take the reciprocal of cos, it would just be the ratio of the hypotenuse over the adjacent, and that's all that ratio means. Okay, so far we should know a couple of identities from first year. I'm going to quickly show you where they come from, because I think that'll help us to remember it. So again, it all just comes from a right angle triangle. Okay, so if we have a right angle triangle, we know from GCSE that Pythagoras theorem works, doesn't it? So I could say from this triangle, h squared would equal O squared plus A squared, just from Pythagoras. If we divide throughout by h squared, that would give me 1. O squared divided by h squared plus A squared divided by h squared. I'm going to write that as O over h all squared and A over h all squared. Can you see why? What is O over h? It's just sine theta, isn't it? So the identity that we've been using in first year, sine squared theta, plus A over h, which is cos squared, would be equal to 1. Okay, and if you want to work out tan theta, we can do it as sine over cos, because if you do this divided by this, you get O over A, the h's cancel. Right, so don't forget, all this stuff just comes from a right angle triangle. Okay, so far we know sine squared plus cos squared equals 1. We've got these new ratios, sec, which is 1 over cos, cosec, 1 over sine, cot, 1 over tan. We're going to be looking at, in the next video, solving equations involving sec and cosec. So, bit of a recap on how we solve from first year. I'm going to do everything in radians. Don't forget, if the question is in degrees, if you get 180 degrees, that's the same as pi. 360 is the same as 2 pi. But just because most of this content in second year will involve radians, I'm going to just use radians for this question. So imagine if I said solve sine x equals 0.5. Now, they will never give you a question like this, because there's actually an infinite number of times when the sine wave would equal 0.5. You can see in my little sketch we've got 4 answers, haven't we? So what would happen if they give you a question like this? They would also give you a domain. They would say for x is between 0 and, I don't know, 4 pi. Okay? So you can do this on your graphical calculator, but remember, when you take sine inverse, if you do sine inverse of 0.5, all the calculator does is it only spits out the first answer. It's called the principal answer, and it gives you the one that's closest to 0. So if I do sine inverse of 0.5, the calculator will tell me it's pi over 6. So that value that we get there, the first value, is pi over 6. Now, if you think about the symmetry of the curve, there are obviously more answers between 0 and 4 pi. Okay, this answer here is the same distance away. That distance from 0 is the same distance from pi. So the first rule that we use for sine, if if we do pi minus our first answer, so if we take away our first answer from pi, it gives us our second answer. So that would give us 5 pi over 6. Remember, you always do that first, no matter what. Like if you've taken sine inverse, just do pi minus answer. Then you look at both your answers and say, are they allowed? Yeah, they're fine. They're both between 0 and 4 pi. Could we get any more? And then we realise, well, the sine wave repeats every 2 pi. So to get to the next answer, we can just add 2 pi on. So if we add 2 pi on, that would be 13 pi over 6. And then we can also get another answer by adding 2 pi onto this one. And if we add 2 pi onto that, that would be 17 pi over 6. Okay, so the first step is to do pi minus answer. Next step, after you've done that, is you can add or subtract multiples of 2 pi to get to other answers. Okay. So there are similar rules for cosine and for tan. I'm not going to show you where they come from the graph because you've seen them before. You maybe have a quick sketch and figure it out, but basically these are the rules that we need to remember. If you've taken cos inverse, you have to do 2 pi minus answer. Tan inverse, just add on pi because tan repeats every pi, it's a little bit different. Once you've done that first step, always do that step first. Then look at your two answers and then say add or subtract 2 pi to get the next answers. Okay, so the last thing we're going to do in this video is just to show you where these new identities come from. So we've got this identity sine squared plus cos squared equals 1. Remember, it just comes from Pythagoras with a right angle triangle. And we can define new identities for sec, cosec and cos squared. Okay. Remember why this identity was useful in last year. If you had a question, say for example, if it was cos squared theta plus sine theta equals 0. If you were trying to solve something like this, you'd have to realise, well, I've got two different trig ratios, and you can replace the squared term, can't you? So I could replace cos squared with 1 minus sine squared, and that'll just give you a quadratic in sine that you can solve. Okay, so we're going to be looking at similar questions in the next video with like cosec squared and cos. Okay, so we need to get some new identities first. Start with sine squared plus cos squared. We know it's equivalent to 1. And divide everything by cos squared. Okay. The other identity is if we start with sine squared plus cos squared and divide everything by sine squared. Possibly pause the video and see if you can get to the new identities before I show you what to do. Okay, so if we divide everything by cos squared, we've got sine squared over cos squared. Cos squared divided by cos squared is just 1. And 1 divided by cos squared. Okay, so what's sine squared divided by cos squared? Well, we know sine over cos is tan. So that would be sine over cos all squared. So we could write that as tan squared. One over cos is sec, so 1 over cos squared is sec squared. And that is going to be important that you remember that identity. You're going to be using that a lot in A-level maths and in further maths as well. Okay, next one. Divide everything by sine squared. So sine squared divided by sine squared is 1. Cos squared divided by sine squared. And 1 divided by sine squared. Okay, so we've clearly got 1 plus cos over sine, don't forget, is the reciprocal of tan, because tan is sine over cos, so cos over sine squared would be cot squared. And 1 over sine is cosec, so 1 over sine squared would be cosec. And that's the other identity that we're going to need to remember. Okay. So that's basically a recap of all the stuff that we need to know up to this point on trig. and then in the next video we're going to look at some exam style questions where we solve various equations using these trig ratios. Alright guys, thank you.